Late summer completely as soon as next year. Sometime between next year and 2020 is most likely, we believe. And as you'll read the caption, it says that shallow ledge of submerged sea shelf is estimated to contain between 500 and 5,000 gigatons, billion tons of methane.
Alaska's second largest city is dotted with pockets of permafrost. The sinkholes, collapsed roads, and tipping houses are clues to places where it has warmed. But now measurements around Fairbanks show that in many places, permafrost temperatures have risen so much that it is only 1 degree below freezing. Romanovsky has planted 45 boreholes deep in the permafrost all over Alaska. The results show that permafrost temperatures have warmed as much as 2 degrees Celsius in the last 20 to 30 years. Normally, because of the heat emanating from the center of the Earth, permafrost should be warm at the bottom and get colder as it reaches the surface. But exactly the opposite is happening. Romanovsky's data shows that since the mid-1980s, the temperatures in permafrost have gotten warmer as they creep towards the surface.
And this warming is 100% effect of changing in climate, warming in air temperature.
If permafrost is around the lake and thawing beneath the lake will emit a lot of methane.
Even small releases of methane from the soil under these frozen lakes can make permafrost thaw more. That can help form more lakes that will release more methane, and so on and so on.
But let's go to the Arctic. This is a view of the polar ice cap in late summer when it's at its minimum in late summer of 1980. Here's one data point just a few years later in 2007. And lest you think I'm cooking the data, here is the record where each color represents a different month of the year, late summer being the lowest. And recently scientists began to realize that they could no longer plot the decline of ice in a linear manner because it was behaving in an exponential manner. The Arctic sea ice is decaying exponentially, and it may disappear in summer, late summer completely as soon as next year. sometime between next year and 2020 is most likely, we believe. Returning to the Arctic region, I want to point your attention to that area, a submerged shelf off of Siberia that is approximately 70 meters, about 200 feet below water. During ice ages past, it was above water, and there was abundant life there at times. And now that life is decomposed under the sediments of that East Siberian Arctic shelf and has turned into something else. Here's another view, a map view of the East Siberian Arctic shelf. And as you'll read the caption, it says that shallow ledge of submerged sea shelf is estimated to contain between 500 and 5,000 gigatons, billion tons of methane, a huge amount. To give you a sense of the magnitude, there are approximately 5 gigatons of methane in the atmosphere of Earth today. And we are talking about from hundreds to thousands of times that amount contained in that one shallow ledge. What you're seeing on this slide is the release of methane from one of several hundred plumes that were discovered when explorations went up there in 2007. And the notation that methane is approximately 86 times as powerful a greenhouse gas as CO2. Now, you will see variation in that number for the following reason. When the methane is emitted, it's estimated to be above 150 times as powerful a greenhouse gas as CO2. Over 150 times as powerful. Now, Dr. Shakova and her team estimate the volume of methane currently being released at approximately 50 gigatons. That is 50 billion tons of methane. It's a pure estimate. There is no way of knowing. It could be vastly more. The question of how quickly, we don't know. Now, that 50 gigatons would represent 10 times the methane content of Earth's atmosphere today, and would more than double the Earth's burden of greenhouse gases, including CO2. That is, we would go from a 400 parts per million CO2 world to the equivalent of 800 to 1,000 parts per million. Now,
at the moment, we have to rely on Shakova and Semiletov, who've been doing that work. And they have then expert knowledge of the seabed conditions, and they're the ones who are estimating the 50 gigatons. So that could be revised up or down if further work is done in that area.
And do you think civilization could survive a 50 gigaton release of methane?
No, I don't think it can. Collapse of civilization is what's going to happen, because the world won't be able to sustain anywhere near its present population. So the result will be chaos and warfare.